Hello and welcome to Maths with Mr Amison. In this video we're going to be doing our second video on circle theorems, looking specifically at angles that are at the circumference of a circle. We'll start off with a few examples. I'm going to show you the example, then talk you through it, and then you can have some time to copy it down and have a go yourself. Feel free to pause whenever you need to. So in these two examples, we're using the fact that for the first example, angles in the same segment are equal, and for the second question, that opposite angles in a cyclic quadrilateral are sum to 180. So for this first example, angles in the same segment. So in this case, we have angles coming from this point and this point, from there to there to there. So we have an angle here, and we have another angle in the same segment, a segment being when you split a circle in two by a chord. So this is a segment here, and then the other side of that chord here would be a segment as well. This angle and this angle are both in the same segment. So both of these angles are equal. And you can, if you think about it logically, if I drag this angle around any point on this circle, if I keep these 2 points the same, I'll get the same angle. Alright? And if you think about why that is, if I had the angle at the center here, any of these angles would be half the angle at the center. So any of these angles would be half of 104, so they're both 52. So these angles are in the same segment. Now, the usual shape for angles in the same segment is a bow tie shape. The bow tie does not necessarily have a center that crosses in the middle. It might do, but doesn't necessarily have to. And all four corners, all four vertices on the corners of this bow tie touch the circumference of the circle. It's important to note that none of these points are at the center of the circle. This only works if all four of these points are on the circumference. Okay, you can cross anywhere it likes, but each corner has to be on the circumference. In that case, then these are both the same, so this has to be 52. Because that's 52, these angles in a triangle must add up to 180. So x plus 5 plus 52 is 180. Which means x has to be 123 for this to make sense. Okay. In this question here, this is a cyclic quadrilateral. Again, all 4 points of this shape, of this quadrilateral, are on the circumference of the circle. That is important. If any of those points are not on the circumference of the circle, then this does not work. When we have a cyclic quadrilateral, opposite angles add up to 180 degrees. Therefore, x plus 52 is equal to 180, and x is equal to 128 degrees. Take some time to copy that down into your notes, and then have a go at these two questions here. Now you've had a chance to have a go, let's go through them. So we have this angle here is the same as this angle here because they are angles in the same segment. Therefore, this angle is also x degrees. Now in this triangle, the angles add up to 180. Therefore, we again have x plus 52 plus 5 is equal to 180. So x is again 123 degrees. For the next question, again we have this cyclic quadrilateral where all 4 corners are on the circumference of the circle. So these two angles must add up to 180. So x plus 2x equals 180. 3x equals 180. Divide by 3, so we get x equals 60 degrees. Alright, here are 6 questions for you to try. Question 1 through 4 are standard questions. Question 5 Question 5 is a bit trickier, and question 6 is really quite difficult. See how you do. So here are the answers to those 6 questions. For question 1, x is in the same segment as 73, so x is equal to 73. For question 2, the 73 here is in the same segment as this one, so that's 73. Then the angles in this triangle add up to 180, so x has to be 14. In this question we don't have a cyclic quadrilateral, so we can't use opposite angles in a cyclic quadrilateral sum to 180. We have to use the fact that the angle at the centre, here, this side of the 73, is double the angle x. So this angle here is 287 degrees because angles around a point add up to 360, which means that x is 143.5 degrees. For question 4, first thing to recognise is that this 2n and this 80 add up to 180 because this is a cyclic quadrilateral. The 2n is opposite the 80, which means n has to be 50. If this is 50, then the 4x add 50 has to be 180, which means 4x has to be 130. If you divide 130 by 4, we get 32.5 degrees for x. For question 5, we have to recognise that this x is in the same segment as this angle up here, and we also have to recognise that this 180 degrees is the angle at the centre. So this angle up here is 90 degrees because this makes a semicircle. So 34 plus 90 plus x from our angles in the same segment would equal 180. So x will have to equal 56 degrees. For question 6, we end up with simultaneous equations. We get x plus 2y is equal to 180 because these are opposite angles in a cyclic quadrilateral, and y plus 3x is also equal to 180 because they are opposite angles in a cyclic quadrilateral. I've written them down here. And then if you're not sure about solving simultaneous equations, it's worth recapping that. But we can multiply equation 1 by 2 to have the same coefficient in front of our y's. So if I do that, I get 6x plus 2y is equal to 360, right here. And then I can do equation 3, take away equation 2. 6x take away x, 6x take away x here is 5x, and 2y take away 2y, they cancel out, so that the y value is gone. 360 take away 180 is 180, which means that we end up with 5x equals 180. So x therefore equals 36 when we divide by 5. So thanks for watching. I hope you found that useful. Bye for now.